with GE Learning and Development. While you're waiting for this session to get started, I'd like to give you an insight as to how we prepare each session's content and what you can expect as the session progresses. Once we decide on the topic, we build a storyboard of content working with various subject matter experts like technical support, engineering, and product management teams to determine what the precise content should be based upon the latest customer interactions. From there, we determine how best to create that content and whether or not we should pre-record certain elements to offer improved quality of content and delivery in order to provide the best learning experience possible for our students. So this session will involve both live and pre-recorded elements, which also includes Q&A sessions where we'll open the lines for two-way interaction. Your session facilitator will be with you throughout the session and will be communicating through the chat line, picking up questions, and then responding to those questions during the live Q&As. A couple of things I'd like to emphasize are, first, we use a program called BlueJeans to deliver our online sessions. And as such, it's important for our students to make sure BlueJeans is properly loaded. What I mean by that is BlueJeans requires certain plugins to be loaded based on the type of PC you're using, so make sure this is done before the session starts. You should also do a speaker and microphone system check ahead of time as well to avoid any unnecessary interruptions throughout your session. The second question is always, will this session be recorded and made available online? The answer is yes, absolutely it will be. We generally post these sessions on our YouTube channel within 1 to 2 weeks of their completion here. Thanks for watching and good luck with your studies.
This overview will cover these topics: the introduction of the 8 series, hardware, software, features, application, function block and ANSI code, and lastly, order code. Introduction. 8 series is GE's next generation protection and control relays with comprehensive protection asset management functions designed for oil and gas, mining and distribution utilities. There's some new technology and design used in 8 series, such as elimination of electrolytic capacitors, field swappable power supply, advanced diagnostic algorithm, 2 milliseconds protection scan rate, IP54 rated construction, conformal coating, interoperability, cybersecurity, environmental module, covered under GE 10 years warranty, environmental stress screening. Multilink 8 series relay platform of protection relay shares a common hardware, firmware, and PC setup software. The relay in this platform includes 850 feeder relays, 869 motor relays, 845 transformer relays, and 889 generator relays. The product identification label is located on the side of the panel of 8 series, which indicates the product model, serial number, and date of manufacture. Some new technology used in 8 series are no electrolytic capacitors, which increased quality and reliability for continuous operation, and also that annual exercise of the capacitor is no longer needed. Built-in field swappable power supply, which extends the usable life of the relay. Enhanced relay drawout construction, which provides simplified fleet management, simplifies testing, commissioning, and maintenance. IPC 8-610 E-Class 3 manufacturing standards, which is the highest industrial standards for electronic manufacturing. Harsh environmental conformal coating, which is standard on all printed circuit boards, delivering higher reliability and extended relay life. Extruded aluminum chassis delivered optimal operating performance. Relay is housed within an IP54 rated construction, and this relay is completely lead-free design. The front panel of the relay, which has a big graphic control panel, GCP. On the GCP, there are 5 soft keys which corresponding to the labels, and there are 17 LEDs indicators. Below there are 3 push buttons, programmable push buttons, and there are 7 keypads which can be used to navigate through the menus. There's a front panel USB port which can be used for quick connection to the PC software, and there's also a self-captive screws on the draw-out handle which can be used to pull out the relay out from chassis. On the rear side of the relay, there's 1 grounding screws, so there's no need for the second filter grounding like the old SR relays. This is the power supply, and this is the low voltage I/O, which is used for the RTD inputs. Then the standard communication, which is used for the IREG-B, RS-485, and copper Ethernet. There's the advanced communication port for the fiber optic ports. On the high voltage I/O, these are for the contact inputs and outputs. And this portion is for the analog inputs, for the CT and VT. For standard 850, it can have only 1 VT-CT inputs on the J card, but for the 869, 845, and 889, which requires 2 analog cards to create the differential protection. So in that case, they need to install both. The dimension of the relay, which is the same cutout as the old SR relays like 750, 469, 745, and 489. The front panel portion dimension is 9.9 in height, 8.42 in width, and depth is 1.55. The body part of the relay height is 8.84, width 7.15, and depth 7.55. The maximum weight of the 8 series relays is 9 kilograms or 20 pounds. Software. 8 series setup software. 8 series software is used for program and modify settings, load and save setting files to and from a disk, read actual values, monitor status, read pre-trip data and event records, get help on any topic, upgrade 8 series relay firmware. The following minimum requirements must be met for the software: dual-core processor, Microsoft Windows 7 or 8, 32-bit or 64-bit operating system, at least 1 GB free hard disk, at least 2 GB RAM. Software can be installed from either GE and Vista CD or from GE Multilink website at www.gegeditalenergy.com. For this 8 series software, here is the quick connect for the single relay connection, and there's also a device setup for the multiple relay connection. There's a shortcut for the quick access to the event recorder, oscillography, protection elements, phasers, digital IOs, and the maintenance. There's a upper portion is for the online settings, and the lower portion for the offline settings, which can be used to create offline setting files and then upload to relay later. Here's a quick setup for the 8 series 850. So the relay can be set into service, and the relay nominal frequency be set to 60 Hz or 50 Hz. For the current sensing, the CT primary can be set here, but not for the secondary because it's fixed with the relay order code. And the voltage sensing, the VT connection and VT secondary VT ratio can be set for both phase and auxiliary VT. For the protection element, there's a setting for the phase, ground, and neutral time over current and instantaneous overcurrent. For the 8 series relays version 1.2 and higher, it can be used to convert the old SR relay setting files like 750, 469, 745, and 489. For the old SR setting files in 16-bit format, these setting files must be updated into 32-bit format by using the latest Vista SR software. And this is the checkbox to use for the conversion of the old SR setting files into 8 series. In the 8 series software, there's a new drag and drop logic designer, which is much easier and faster to build a flex logic compared with the old reverse polish notation designer. This is a more efficient way to design the flex logic in the software. Eight series platform highlights include enhanced digital signal processing, which delivered through the enhanced filtering technique and protection path of 8 times a cycle. Improved response to CT saturation and other system transient condition, which offers an option to operate IOC based on either the fundamental or from RMS quantity. Advanced communication capability, which includes support of Modbus, DMP3, IEC 61850, IEC 62439, IEC 60870-5-103-104, Parallel Redundancy Protocol, PRP, and IEEE 1588 Precision Time Protocol. Wi-Fi connectivity, minimize system configuration and provide simplified connectivity during commissioning and diagnostic. 2 levels of security. Standard security role-based authentication control, RBAC, and optional advanced security cybersentry. Based on NERC, CIP, and NIST, NIST-IR cybersecurity requirements. High-end cybersecurity such as AAA, authentication, authorization, accounting. RADIUS, remote authentication die-in user services. And syslog helps enable integration with established SIEM, Security Information Event Management System. 3 time references are SNTP, IREC-B, and IEEE 1588. The breaker health monitors overcurrent times, trip circuit, spring charging time, per phase arcing current, and trip counters. Patent environmental monitor measures and provides operating condition information and diagnostic information, which helps to reduce system downtime. And FlexLogic tools consist of 1024 lines, which gives the user maximum flexibility. 8 series can store up to 1024 events locally in the relay non-volatile memory, which means even the power is off, these events recorded are still saved. Harmonic measurement can measure up to 25th harmonics for both current and voltage, including THD. Data logger can save up to 16 analog values selected from any analog values. And for the 850 relays, there's a fault report function which can identify the fault location, fault type, and the elements that trigger the fault. For the 8 series, it has the DFR class transient recorder, can save up to 32 digital and 16 analog inputs. The total length of the transient recorder can be from 31 cycles to 1549 cycles. It depends on the sampling rate. The highest sample rate can set up to 128 samples per cycle, and the maximum storage can be up to 25 seconds. These files are saved in the complete file, and which later can be used for fault analysis. Let's say to play it back with the modern three-phase test set like Dobo, Megger, Omicron. So the user can identify this fault to be an authentic fault or it's a nuisance trip. And this is the front panel display for the single line diagrams and the reading. Unlike the previous relays, it shows only the metered values, and this single line diagram can show lots of information. For example, this 845 relays, it shows the high side and low side voltage levels of the transformer, and also the condition of the breakers and meter values all in one screen. And this is one example of the environmental health report, which records the ambient temperature, humidity, and also the surge and vibration. Applications. Multilink 8 series platform of protection relays includes 850 feeder protection system, 869 motor protection system, 845 transformer protection system, and 889 generator protection system. 850 is an advanced feeder protection relay that provides high performance protection, high density I/O, extensive programmable logic, and flexible configuration capability. With protection and control logic, 850 allows for simplified coordination with upstream and downstream disconnect devices. Additional control features such as auto transfer scheme, load shedding, cold load pickup, and auto reclose are also available for optimal protection and control of industrial and distribution networks. 869 relay has been designed for protection, control, and management of medium and large induction and synchronous motors. 869 relay offers a powerful solution for critical motor protection application with advanced thermal model and voltage-dependent curves for high inertia loads. 869 implemented many easy-of-use features such as single screen setup, for faster motor configuration and startup. Motor health report providing detailed motor diagnostic, enabling quick and easy identification of motor issues. 845 has been designed for protection, control, and management of 2 and 3 winding power and distribution transformer in both utility and industrial applications. 845 provides advanced functionality for a wide range of transformer application, delivering high-speed protection, advanced transformer monitoring and diagnostics, like hottest spots, aging, and loss of life. 845 also integrated with the DGA devices, for example, Transfix, which can analyze 9 types of the gas produced when the fault occurs. So when combined with the 8 series relay protection element event recorder, so the user have a better understanding of the fault gases provided associated with the fault types. 889 is a generator protection relay used for medium and large generators. Function block diagram and ANSI code. Let's take a look at 850 feeder protection relay block diagrams. In this diagram, we can see this current associated protection element and voltage associated element, and some element use the both. So we have the 50 breaker failure, code load pickup, 51 phase TOC, 50P, phase IOC, and directional overcurrent, negative sequence overcurrent, negative sequence instantaneous overcurrent, negative sequence directional power, and the cable thermal. And what metric ground fault, neutral TOC, and neutral IOC, and neutral directional. And we have the ground, instantaneous, and time overcurrent, and directional. Also sensitive time overcurrent, instantaneous, and directional. Then from the voltage element, we get under voltage, phase under voltage, phase over voltage, neutral over voltage, negative sequence over voltage, VT fuse fail, frequency element, under frequency, over frequency, and frequency rate of change. Then we have a synchro check element 25 to use both the voltage from the bus and from the line. We also have the auxiliary under voltage and over voltage. For the control part, we get the 79 auto reclose. Here's the 869 motor protection relay diagrams, and it has the same platform as the 850, most current and voltage elements, and it has some special protection elements just for motor, which is the thermal model. This is different with the thermal model in the 850, which is the cable thermal model, and this is the motor thermal model 49, and also it has the 87 differential, which is a dual slope differential characteristics. And for the voltage element, it has 47 reverse voltage, phase reversal. Okay, so that's the, let's take a look at 845 transformer. It has again all the protection for the like 850 platform current voltage protection, and depends on the order code. If it has a voltage element ordered, it may have some voltage element like a 27. It also has the unique protection element like 24 volts per hertz. The main protection is again the 87, the differential. This can be a differential for the 2 windings or 3 windings. And it has a 49 thermal element, but this is different with the previous relays, which this includes the hottest spot, the aging and loss of life. And finally, we got a comparison table between the 4 relays. We can see that each protection relays and the availability for each type of the 8 series relays. And for the 850, we get the most common platform element, current voltage. And be careful that certain features, for example, this directional, phase directional, neutral directional, ground directional, and this has to be enabled in the order code. So when you buy a basic order code, you don't have this advanced protection like directional. And for the 869, it has its own unique protection, is the thermal model and the directional. For the 845, it has the volts per hertz, and it has again the directional. This directional will cover for both 2 windings and 3 windings. And 89 has the distance, volts per hertz, and of course it's loss of excitation. That's the main protection of the generator. And 78 out of step, and of course differential. So that's a comparison of all the 4 8 series relays. Order code. In this part, I'll demonstrate how to order 8 series relays from GE Digital Energy website. So this is the 850 relays. We can pick up the language and the CT secondary, and for the second part of the analog input is not needed, and there's an option we can choose the standard ground or the sensitive ground. Then for the power supply, it's a standard, and from the low voltage I/O RTD from the firmware 1.4 and higher, it's available for the 850. And for the high voltage I/O, which is used to select the contact outputs and inputs. Faceplate standard color graphic display, and the current options we can choose basic, advanced, and see this option is standard advanced only because we get some options previously selected. So this in this order code ordering screen is all this information associated. You have to pick a certain preconditions in order to have this option, or vice versa. If you selected one option before, you only get some available option after. So this now we get because we selected sensitive ground, for example, in this case we got only a standard and advanced. And see, for now the voltage, I got only advanced options left. And for the control, we can choose basic, standard, and advanced. And for the monitoring, we got the basic and advanced, which has a breaker health monitoring. For the communication part, if you use only the copper Ethernet, you can choose SE, but if you want to use 61850, so you have to pick the 2E. And the fiber optic connector is standard ST connector, and wireless, you can choose Wi-Fi or without Wi-Fi, and cybersecurity, you can choose the basic and advanced cyber sentry. And the same for the 869, we got options to choose the second analog input, the K card, which is standard now because to create the differential protection, we must have the second analog input. So we have to have both J card and K card. And for this rest part, it's quite similar like the 850. So for the 845, we got lots of options to choose for the different type of the transformer. We got the 2 windings. And 2 windings we can choose without voltage or with voltage. Without voltage or with voltage. Or we can choose the 3 windings with voltage. So that's the order code part for this 8 series.
Here is a demonstration of the front panel operation of 869 relay. And we are now at the front panel color screen of the 869 relays. We can see the single line diagrams and also the metered values of the current, energy, and the power. So that's the new feature of the firmware 1.4. We have the single line diagram. One picture worth 1,000 words. So we see the bus voltage level and the breaker and CT and motor. And if you want to see more parameter, you can press the values key and you can see the individual current and voltage. And we can see this VAN now is 40 kilovolts. So why this bus voltage is 27 kilovolts? Because this bus voltage measures the average of 3-phase voltage, line-to-line voltage. So now we get only single-phase test set RTT injected to the relay. So we get the line-to-line AB is 40 kilovolts and BC is 0 and CA is 40 kilovolts again. So the 80 kilovolts divided by 3, that's around 27 kilovolts. That's why we see this 27 kilovolts in the bus voltage. And from the values button, we can see the more parameters of current and voltage. Now if I increase some current injection from my RTT, I can see the changing of the current. And also we can see the other parameters like a relay, motor thermal condition, starting, capacitor, capacitance, thermal capacitance used, TCU. And also we see the metered, can see the metered power and energy. And if we go press the phasor, we can see the phasor diagrams of the ABC to neutral and the current. Because I don't have a single phase, 3-phase test set, I'm just doing the single phase, I cannot see the vector of 3-phase. And also we can see the sequence of positive, negative, zero sequence, voltage, and current. So press escape key. I can go back to the main menu. So the main screen, and we can see have a sum of 5 buttons, and with each labeled labels. So the target, we can see the whatever target message you have in the relay, and once any protection element operated, you always get a target message, and we can check the status. And one important information I like to check first when I get a relay is the relay firmware and order code. Even we can check the order code from on the side of the chassis. There's a identification label, but I still want to make sure that the relay has a correct order code and firmware matching to on the label. So you go to status and you press the button until you see the info. So here you can see the relay firmware is 1.4. That's the latest released firmware. And also the relay auto code is 869. That's a motor protection relay. Okay, so come back to the status. And you can check lots of information under status. Like here we can see the motor. For example, I'm injecting some current. Now it's motor considered that's a starting current, and also the thermal capacity being used is 100%, and the other related parameters. So you can also check the breaker conditions. Now the breaker status is unknown because I don't have the 52A and B turned on. So if I turn on the 52A, now it shows it's closed. If I turn off, then it shows open because I turn on the 52A. I will show the configuration of the breaker later. So there are other parameters. It's not set for the. So now we come back to see the single line diagram. We see this is the red color. That means the breaker is open. And if I change to close, it shows the green color means it's closed. So the green in the utilities means that it's running, it's making the money. So that's the running status. And if I come back to the second, the breaker, I mean not this one. So the following the contact input, we can see that the my contact input 1, which I set for the 52A, is closed. So that's the, you can check the contact input starts from here, and you can also check the relay condition. If the relay, trip, alarm, any contact operated, you can check the contact here. And here's the relay condition. Once you have any relay operated, either the trip, alarm, auxiliary relays, you can always see the relay status here. And now the next you can check the virtual inputs, and you can check virtual outputs. So once you have a flex logic editor, you program a flex logic, and you can check the virtual output 1, 2, 3 status here. And there's a flex states, and you also have columns. The info is most important. You can check the firmware version, and also you can check both hardware and software. And there are other settings, status of the clock and the PTP. So that's for the precision time protocol settings status. So in the metering part, that's the lots of information you can get is the when you have an injected current voltage, you can see lots of parameters. You can see summarized voltage current 3-phase. You can see the single line diagrams with the breaker conditions, and also you can check the phasor diagrams, or you can check the single J card for the current, or if you have second card for the K card. And also you can check the voltage. You can check both the line to neutral, line to line, both the phasor and RMS values, and also the frequency. Because this is 869 relays, it shows only the CT, VT frequency. But if you have a 850 or 845, which has a frequency rate of change protections, you will also display the frequency rate in this metered screen. And also you check the harmonics, as we know that for 8 series relays, we can measure the harmonics up to 25th. So it measures both the current and the voltage, and also the THD. It shows also the power, the apparent power, reactive power, active power, and the power factors. And it shows also the energy and the demand. Okay, here's the new features only for the 869, because actually now in the new firmware from 1.4, RTD is also available for the 850. In the previous version, this is only RTD is only available for the 869. So this is the RTD input. Actually, I got one RTD connection connected from the test at RTT, so I can see the metered RTD values. So if I go to the RTD, metered RTD is 150. If I change the RTT, the resistance, I can see the temperature is changing too here. So that's the metered RTD, and also you get flex elements. All this you can see under the metered values. So I go back to the metered, and that's probably most of the metered values. I'll escape to the next, the set point. In the set point, you get lots of parameter you can program. And one important parameter, once you get the relay, you probably get the relay out of service. This in-service light is not green, it's probably the orange color. So what you want to do is set the device and installation. So this is the settings. You can see this service relay in service is ready. So I can change it to not ready. So now I see this in-service light turned into orange color. So I can change back. It's ready, so it changed to green. Another thing you might need to change is the security. Because this new cyber security features of the 8 series, it will prevent any unauthorized user to change the settings. So we get different levels. So now I'm in the admin levels, and if you get the relay, you're probably in the operator level, so you don't have any access to change the settings. You need to change the levels from the default operator to administrator. So I'll stay in the administrator, and this is the thing. And also you can set your own password for the operation. So by default, the factory password is 0, but you can change your own password. We get communication part. That's the very often used settings, especially for the Ethernet. And if you want to use the 8 series for the IEC 61850 goose message, you have to set your Ethernet port and use the fiber optic ports. So there's two ways we can set the Ethernet port. One is from the front panel USB to set from a quick connection with a USB. Another one we can directly set from the front panel. So in case you don't have a USB printer cable, or for some reason you want to do a quick setting from the front panel, you can do this from the settings, device, comms. So you press the Ethernet button, and you can just type in the Ethernet IPs. So you have two ways. You can press up and down arrow key, or you can type in the, for example, 169.128.0.0. So you can just type in and do the keypad. We got the 2 port settings. That's because this redundancy PRP. So we got port 4 and 5. So you can set both, and they're both connecting to the switch. In case one fails, you still get another one working. And we got other settings like a Modbus. You can set the slave address, for example, the port numbers, and you get RS485, the other DMP, IC 6870 settings in this communication port. And then transient recorder, we usually don't set this in the front panel because there you get a bunch of a long list of these trigger conditions. So you have to have a really long list. That's I don't like to use this front panel. So anything you need an enumeration of the flex operands, I prefer to use the software, so that way you can type in the operand. And this is the transient recorder. You can set the certain condition to capture a certain type of the fault, IEC, IOC, TOC, or whatever, and can capture the both analog and digital. And we also have the data logger, so you can set the saving certain analog meters and, for example, the voltage fluctuation overnight. So you can set like a per second, per minute, per 5 minutes, 10 minutes, per hour. So that can be saved in this data logger. You got the fault report, flag status, programmable LEDs. That's another thing I used to quite often, is that you can set the programmable LEDs. That's another programmable LEDs. That's the thing you can set this front panel programmable LEDs. They have 3 types of the colors. This 2 is not programmable, so let's pick one programmable. Let's, for example, LED 8. So you get 3 types of colors you can choose: red, green, orange. And then you can trigger. This triggered by, you get a long list of this flex operand you can choose. So once that condition met, you will get that LED turn on to that predetermined preset color. And I got programmable push buttons, panels. So that's lots of settings in this under device. And system. This is the most important and most often used settings, because this one allows you to set the CT and VTs, primary. I would not say secondary for the CT, because CT secondary, unlike the UR relays, you can choose 5 or 1 in UR, but for this 8 series, the CT secondary is fixed once you pick the order code. So from the system, you can set the CT primary. For example, here is the phase primary and the ground primary. You get a second card. If you, for example, this really have a J card and K card. So for J card is setting on the card 1, and K is card 2. We need the J and K just to create the differential protection for this motor. And also for the voltage, you can choose the first is the type of the connection. You can choose the Y connection or the delta connection. And then you can pick the secondary voltage, the VT ratio, same for the auxiliary VT. And the power system, You can set 60, 50 Hertz, ABC rotation or ACB rotation, and frequency tracking. Really will enable the frequency tracking to this relay. And motor is very important setting for this 869 because the motor related protection, the setting is mostly based on this FLA. That's the full load amps or full load current of the motor. So always you have mechanical jam, you got undercurrent, you get lots of settings, overload. All this is based on this FLA. So back to the set point, system motor, and you also needed to set this service factor or overload factor, and that's allows the motor to run under certain overload conditions based on this overload factor, and also the thermal protection. You also need to use this overload factor to calculate the overload curves. Nameplate voltage. This is the parameter of the nominal motor voltage, and this will be used in the voltage-dependent thermal motor protection. And you got the emergency restart, and for this relay I set to the contact input 2. So that means once the thermal capacity reaches 100%, you cannot restart motor. You can use this emergency restart. In the old 469 relays, we get the jumpers. You can use a jumper to show this emergency restart. And we get the other settings of the motors, number of start to learn, average, switching device type. You can choose the contactor or breaker. You got the load filter interval settings, and also you have a setting for the second speed motor protection. And this the VFD is the setting. You can choose the variable frequency drive, so you can choose the bypass, or you can also choose the starting frequency. That's for the VFD settings of this relay. That's the motor. Okay, you get the breaker. As I mentioned, I can see the breaker condition in the single line diagrams because I got this breaker set here. So I'm using the breaker contact input 1 as my 52A and the contact input 2 as my 52B. So now in my RTT device, I close contact input 1, so that's my breaker, main breaker condition is closed. Because this setting close relay select relay 2, that's very important setting. This is allows you to choose the relay 2 to be shown as a close or as a relay 2. So now let's go to see check the status of the relay 2 or set point of the relay 2. We go to output relay. We can see that relay 2 is shown as close. Okay, so because if you go to check the check the breaker and close relay select as relay 2. That's why relay 2 is selected as a close. If we choose this as off, that means relay 2 is not picked as a close. So now if we go back to check the output relay, and it shows auxiliary relay 2. That means you can use this auxiliary relay 2 to program any other protection element assigned to this auxiliary. So this is the setting is should be careful. There's you can switch assign the relay 2 either as a close or as an auxiliary relay 2. go back to the set points and flex curve. That allows to program your flex curve for some TOC test. So we will do this later in the software. Okay, so that's it for the system settings. And the inputs. For these inputs, we can have contact inputs. I'm using the F card, so you have 7 inputs. And because I'm using RTT test set, the one setting I have to change is the threshold. RTT I can output only 24 volts DC, so I need to reduce the threshold to 17. So you get 4 levels. You can choose 17, 33, 84, 166. Okay, so this is the contact input 1, and you also get the debounce time settings, which means you have to apply that contact minimum for this debounce time. If your debounce time, let's say, is 10 millisecond, if you apply this DC for only 9 milliseconds, then this contact won't be asserted. It won't consider it is closed. So if you apply 11 milliseconds, that's good. Okay, so that's the settings for input. We got the output, like I'm showing this, we can see each output contact status. Also the virtual output. And the virtual output is used in the flex logic editor. So once we assign some flex logic, you can see this flex logic, but usually we do this in the software, in the flex logic editor. So I'll show this flex logic thing in the virtual output in the flex logic. Okay, so we got the main portion of the set point is the protection. Protection gives you 6 groups, so you can pick different groups for the different conditions. For example, in the certain condition, you choose group 1, and another condition you want to use a group 2. So this switching can be either manually or automatically. This can be done in the control setting. So let's open the group 1. We got the motor protection, current voltage, and frequency. In the motor related protection, we got the differential, thermal model, unbalance, mechanical jam, undercurrent, overload, short circuit, ground faults, acceleration, and underpower. Okay, I'll pick 3 to show some unique features of the 869. So first is the percent differential. We get 2 types of the differential. You can pick the regular internal sum, or you get to choose a core balance. So internal sum, you get a calculated differential current and restraint current, the maximum of neutral side and the terminal side. The core balance, you get this differential current from the terminal, then you get the restraint current from the core balance CT. So let's see the protection. Second one is the thermal. In the thermal model, you get the standard motor curve, or you can choose the IEC curves, or your own flex curve. And also we have this voltage dependent function available for the 869, so you can enable this one in case that have a large motors, you get the voltage involved in the protection, so you can choose this one. Again, this time the nameplate voltage will be used in this calculation. Okay, so the last one is the ground fault. ground fault, we got two type of the CT options. You get to choose the regular 1 M CT, or you can choose this core balance 50 to 0.025 CBCT. That's the option for this ground fault. Okay, so that's for the protection part for the current. So I mean the motor. Now we see the quickly current. You get the regular current protection like 850. You don't have this too much advanced protection like 850. You get more current protection than the 869. So that's protection, and if you go to the next is the monitor. So you can set the monitor for the breaker, for the broken culture bars, and some functions like demand, pulse outputs, and digital counters. Okay, so go to the after the monitor is the control. Control, you get lots of settings, and one important is the setting group switching. So you can switching from group 1 to 6. And also you get control for the motor starting, switching device. You can choose the breaker or the contactor, virtual inputs, trip bus, which is a big OR gate for the many inputs, and breaker failures, and VT fuse fails. So after that you get the flex logic. We prefer to use this in the software. And RTD temperature. You can set the trip level and alarm level. For example, this trip level is 155 Celsius, and you got the alarm. And this one is disabled. So the setting is 130 Celsius degree. And last one is the factory settings. And the factory settings give you the access to the factory modes, so you can set the settings to the factory clear. You can see some like voltage, current, cutoff level settings. So you have to have this factory password into the factory modes. Okay, so after the set point, we get come to see the records. A record's most important one from the front panel is to check the event record. So event record give you all these event records, and with the timestamp for each event. For example, the powering of the relays, the breaker closed, or the phase ILC tripped, operated. Because you calculate the time delay between two events, and to know that the time delays. And also you get the data logger, transient recorder, and some, for example, transient recorder, of course we want to see this in the software, not from the front panel. And we got some digital counter, clear records, and all this information. Some you can see from the relay front panel, and some one you prefer to watch from the software, like data logger. You can see the plotted fluctuation curves, and that's good to see from the front panel. So that's concluded this HMI human-machine interface demonstration of the 869 relay.
In this segment, I'll demonstrate how to do the 869 relay quick connection, quick setup, and a test of the motor thermal curve. So first, I plug in the USB printer cable to the front panel of the relay and open NVISTA 8 series setup and click Quick Connect. So Quick Connect connected. I got click open the under the quick setup. I can set up the system settings. So for this relay device is ready, 60 Hertz, nominal current, and motor full load amps, overload factor, nameplates, and I also configure the breaker conditions 52 and B. And go to the protection element. I can set up the trip function for the thermal model, and I will going to test this overload curve, curve number 1. So I pick up the time dial to 1. I'm going to use the standard curve, and so I can save this setting. Okay, close this quick setup, and to monitor the status of the motor, I like to open the metering and motor load. So now I'm injecting some current to the relay. So I measured 1.99, that's roughly 2 times of the FRA. Because what I'm going to test is the motor load curve, and from the theoretical curve we can see this when the pickup is 2 times the FRA, I should get 29 seconds at time dial 1. So I will apply this 2 times and check the trip time of this motor thermal curve, and also I will open the motor status. So before that, I will check the motor capacity. Now it's already 100, so I have to clear the thermal capacity. This thermal capacity is configured in the motor, so that's under the set point system motor, and I'm using the contact input 2 to clear the motor. So I'm going to turn on this contact input 2 and to clear the motor thermal capacity. So now we see this capacity is cleared to 1. Okay, I will turn off the RTT, so that means the thermal capacity is 0, and once I turn it on, 2 times of FRA will apply to the relay, and I should see the relay trip to after 29 seconds. And also when I want to see this not only the target message, but also I want to use one programmable LED to monitor this, I can pick up one programmable LED under devices, programmable LED. So I'm going to use LED, the last one. So I already programmed this LED as the thermal operate. So LED 14. So that means once I applied this 2 times FRA, LED 14 will turn on. So now let's get ready for the RTT. So what I'm going to do is also monitor the front panel. So I will start the timer and also apply the current. Now I'm going to use RTT test set to apply 2 times FRA to the relay and to test the relay overload trip time should be 29 seconds. And also I'm using one iPhone to measure the rough trip time. So I'm going to apply the current and start iPhone timer. So the relay should trip after 29 seconds, and I also should see the LED 14 at the bottom should turn on after 29 seconds. Okay, so I see the LED turned on at 29 seconds. I'll stop my timer, but to see the more accurate operating time, I should not use the iPhone, but use event recorder of the AnaVista. So I will start the AnaVista record and check the time between the thermal operate to the motor starting. So I get 28.99, so that's very close to the theoretical 29.16 seconds. And so with this test, I proved that the 869 overload curve is working the same way as the old SR 469, 369, and 269. In this segment, I'll demonstrate how to use 8 series setup software to program the Flex Logic in the Flex Logic editor. So first, I'll connect the relay and generate one offline setting file. So right-click Quick Connect and choose Read Device Settings, and I'll give this relay a setting name. So I'll call this relay 0, and click Receive. So it's downloading the settings from the relay. So now I have a offline setting windows and have one generated offline setting file, relay 0.cid, and I can open my Flex Logic Designer. So in this demonstration, I will program some a small logic diagram. So this is the diagram showing the 52A and B, and assign this to the virtual output 1. So this is actually an XOR gate. So either 52A or B, that must be 1 to be closed, another one, another one open. So 1 to be 1, another one be 0. So then it's a valid breaker condition. You cannot have both 52A and open or both 52A and B closed. So this is the diagram. We're going to program this in the Flex Logic editor. So we're going to use the contact input 1 from the relay as the 52A and contact input 2 as the 52B. So first we need to choose the IOs. We need 2 inputs, contact 1 and 2. So this we can choose from the contact family of the contact input 1 on and number on, and the second one is the input family of the contact input 1 and change to 2. So we got input 1, 2. Now we need to apply the AND gate. So this one will need to click the Booleans tab. We need one AND gate. Then we need another AND gate. We need one OR gate. So we need one NOT gate. Okay, so we need to draw the lines. We need to enter and this one will assign this to the virtual output. Okay, so this virtual output will reflect to the breaker valid condition, valid status. So to monitor this one, we also need to assign some programmable LEDs from the front panel. And first I will compile this equation. So, and I'm going to assign some flex programmed LEDs. I'm going to use the 3 LEDs to monitor the status. So I'm going to assign the LED 8 to be orange color for the contact input, and LED 9 orange color to be the contact input 2, and LED 10 orange color to be the virtual output 1. So once I upload this setting to the relay, if I turn on either contact 1 or 2, I should get LED 10 turned on. If I turn on both, or if I turn off both, and then LED 10 will not turn on. So now I'm going to upload this file to the relay. So I choose right-click the setting file and click Write setting file to device, and I pick up this quick connected device. Okay, it says please reboot the relay to view the changes. So I have to reboot the relay. Okay, now the relay is removed and we see that front panel, the in-service light turned to yellow. We have to change back to in-service. So I could do this time from the software to the quick connection and choose device installation and set this to not ready to ready. After rebooting the relay, we can use the RTT test set to check the status of the relay. So we can turn on the contact input 1. We see the LED 8 is turned on and also LED 10. If I turn off 1 and turn on only the 2, I see also LED turned on. If I turn on both, LED turn is off. And if I turn off both, LED turn is off. So that proves this contact input 1 and 2 is an XOR gate. And this is the flex logic equation we programmed in this drag and drop editor. So compared with the old reverse Polish notation editor, this is a really faster, easier way to do the flex logic equation program. And that concludes this demonstration of the flex logic editor in the 8 series setup software. In this session, I will demonstrate IEC 61850 goose message testing with two 850 relays of firmware version 1.40. So first, we will create two relays in the device setup in NVISTA software. I use new site 1 and relay 1. I already pre-entered the IP address with the USB port. Relay 1 is 1.1.1.1. Read order code. Okay, now I'm going to add the device 2, that's relay 2. And again, the IP address is preset with USB port. This relay 2 is 1.1.1.2. Read order code. Okay, so now I need to get the MAC address of these two relays. So relay 1, I have to log into administrator, enter the default password 0. So the MAC address is under the communication information. So this is the relay's MAC address. So I'll copy this into my notepad. Same, I'll do the same thing for the relay 2. Logging at administrator, password 0. Okay, so this again, I need to copy this MAC address into a notepad. So that's my MAC address for two relays. Because in order to make this goose message multicast, I have to change the first octet into 01. Same for the relay 2. So that MAC address will be used in the set up later. So I'm going to create now 2 offline setting files. I'm going to read the relay 1 setting file. Could give the name relay 1. Click receive. Okay, relay 1 is done, so I'm going to now read the relay 2 offline setting file. Right click and choose read device settings. Give the name relay 2. Click receive. Okay, so now I have 2 offline setting files. I'm going to program the relay 1, and to use relay 1 as a publisher, I will publish goose message of a face IOC pickup and the contact input. And for the relay 2, I want to use its remote input received from the relay 1 and echo back this to the relay 1. So first I open the relay 1 61850 configurator. Okay, so this I need first to set up a goose configuration and goose control block, and I will enter the relay 1 MAC address. Okay, I will call this control block name, give it to relay 1, and I'll call the goose ID relay 1. Now 2 offline setting files are created. I'm going to program the relay 1 first. Open the IEC 61850 configurator. So for this setting tabs, I already programmed the IED name relay 1, and under the goose transmission, I'm going to add a goose control block, and I'm going to rename the control block name to relay 1 and goose ID to relay 1, and I'm going to enter the MAC address 01 for multicast 80540374 and 15. So I'm going to now add some published goose message. So first I will pick the goose message for the contact input, that's GGIO2. Then I'm going to publish the goose message for the face IOC pickup. STR, that's for the pickup. Then I also want to publish the goose message for the operation relays, so that's GGIO6. Now I'm going to open the relay 2. And first I check my settings for the IED, set to IED 2 and the goose transmission. I'm going to add a transmission of the GGIO5. That's the remote input from the relay 1. I'll publish this back to the relay 2. Again, I want to rename this to the relay 2 for the control block and goose ID. And make sure that the pre-copied MAC address is entered here, A0, F4, 03, CF, and A3. On the reception, well, receive the setting from the relay 1, and we got 3 message will be published, so we'll drag them to so this relay 2 will receive 3 goose message from the relay 1, GGIO2, that's a contact input, and face IOC pickup, and the contact output. Okay, so now I'm going to configure the relay 1 reception. So relay 1, I want to receive the echoed back message. So that's the GGIO5. Actually, for this is already pre-entered. So that's the GGIO5. I can just show you how to do this from scratch. So I can remove this one and click Add IED and choose the relay 2. So this is the only one available for pickup. That's the GGIO5. After that, in order to make the relay 1 to publish the goose message of the phase IOC pickup and the contact input, I have to check the relevant settings about the contact input and the relay IOC pickup. So first is a contact input. I want to make sure that the threshold is 17 because I'm using RTT, can output only 24 volt DC. And then I will check the protection, group 1, current, phase IOC. So this is enabled to trip, pickup 0.1, that's good. So at least the RTT output current can drive this 0.1 CT to pick up. So now I'm going to write these 2 setting files to the relay. Right-click mouse and choose Write setting files to device. This is will be the relay 1. Change administrator, password 0. Now the 2 setting files are ready to upload into the relay. I'm going to write the relay 1 to the relay first. Right click mouse and choose write settings files to device and pick relay 1 and change the to administrator password 0. Okay, so this is done, and it says that reboot the relay to view the changes, and we'll reboot the relay from the software. And now I'm going to write the second relay file to the relay. Right click and choose write to relay, relay 2. Change to administrator and password 0. Okay, so setting file is written to the relay. I need to reboot both relays. So I'm going to start relay 1. So under command of relay 1, I double click open. At the bottom there's a reboot the relay, so I click this button. Proceed to reboot the relay, yes. Okay, so the relay 1 is rebooting. I'll do the same for the relay 2. Reboot, yes. Now the relay rebooting is done, so I'm going to do the ghost message testing. And before that, I want to set up the oscillography for the relay 1, so I can see the ghost message echo back from originator. So I'm going to turn on the setup of the transient recorder under devices. Okay, so actually this is the preset up, so the trigger ghost message will be the remote input 1, and I want to monitor the contact input 1 and also the remote input 1, so I can see the time difference between the originator and the echoed back to ghost message. Now I'm going to check the ghost status. So relay 1, ghost status is good, ready, it's on, and I also want to monitor the remote input 1. This is waiting for the echoed back goose message. I will turn on the goose 2. Administrator, password 0. So So the relay 2 goose message is ready. Now I'm going to check the status of the relay 2. Check status, goose status, choose administrator, password 0. Okay, so the goose status of relay 2 is on. And I'm going to check the remote input. Okay, so now I'm going to turn on the contact input 1 of the relay 1. So I see the relay 2 remote input 1 is on, and this goose message is echoed back to the relay 1. And now I'm going to increase the current of the relay 1. I see the phase axis pickup is on for the GGIL5. So that means the relay 1 published goose message for the phase axis pickup, and contact output are received by relay 2. And now I'm going to check the relay 1, the oscillography. Okay, so from this oscillography, I can see the contact input 1 and the remote input 1 on. At the bottom, I can zoom in this portion. Okay, I drag the cursor. I can see the delta time between these two goose message is 4 milliseconds. That's the contact input 1 publish a goose message through relay 2, and relay 2 use this as the input and echo back to the relay 1 as a remote input 1. So that's total time is 4 milliseconds. And that concludes this demonstration of the IEC 61850 goose message testing with two 850 relays of the firmware version 1.40.